Okay, here's number one from the exit slip. That will be basically the same format as Monday's final exam. So here's exponential regression data. You have time, 0 through 5. You have population, 250 through 3,000. Write an exponential regression equation to model these data, rounding all values to the nearest thousandth. So that's the biggest thing that I've noticed. People are not rounding correctly. Thousandth is to the 3 decimal places. Another thing, some students are writing down y equals ab to the x. The Regents doesn't care about ab to the x. They want to see the number times the number to the x power. Okay, so this will give you your 2 points. It must be written as y equals, and then this part of the equation. Okay, so you need the equation. Now, they want to know the prediction at the end of 7 hours, how many bacteria there will be. You have to plug in 7 for x. That's what I mean by the work. And you plug this into the calculator, and it gives you this. They need you to round this to the nearest 10. And think back to elementary school. 1's place is this digit, 10's place is this digit. So is this number closer to 7,250 or 7,260? The answer is 7,250. Number 2, binomial probability. In the month of February at a ski resort, the probability of snow on any day is 3/4. What is the probability that snow will fall on every day of a 5-day trip to that resort in February? So probability is 3/4, there's p is 3/4. The number of days is 5, and we're looking for all 5 days of success, meaning that it will snow on all 5 days. So that's why n is 5 and r is 5. Second part of the question, what is the probability that snow will fall on at least 3 days of the 5-day trip? And I solved that over here. Let's continue on with the first question. It's 5 choose 5, 3/4 to the 5th power times 1/4 to the 0 power. And this turns out quite easy because 5 choose 5 is 1, and 3/4 to the 5th power is 3 to the 5th power over 4 to the 5th power, which gives us 243 over 1,024. Okay, now the at least part. Since it's at least 3 of the 5 days, 3 is the least number it could be. So it goes 3, 4 to 5. Okay, the probability is the same, the number of days is the same. That means we need to write down this binomial probability expression 3 times. 5 choose 3, 3/4 to the 3rd, 1/4 to the 2nd power. Remember that the exponents must add up to n, right? And this is what the calculator gives me, this fraction here. Now we go to 4. 5 choose 4, 3/4 to the 4th power, 1/4 to the 1st power. 5 choose 5, 3/4 to the 5th power, 1/4 to the 0 power. And these are all 3 fraction probabilities. Add them all together to get 459 over 512. You can also have any equivalent fraction. Number 3, here's your standard deviation normal distribution problem. On a math exam, the scores of 10 students were as follows. Find the mean. Find the standard deviation to the nearest tenth. How many scores from the given data differ from the mean by more than 1 standard deviation? Okay, first thing, we plug all these numbers into our list. Then we hit stat, one variable statistics, L1, hit enter. And you see that x hat is 80, that's the mean. And the standard deviation, not the sample, but the population standard deviation, is 11.7 rounded to the nearest tenth. I sketch out my normal distribution curve. My normal curve, 80 is in the center. I add 11.7 to get 1 standard deviation above, and I subtract 11.7 to get 1 standard deviation below. How many scores from the given data differ from the mean by more than 1 standard deviation? Normally we count the scores that fall within 1 standard deviation. Now we're actually counting scores that are outside of 1 standard deviation. In other words, they differ from the mean by more than 1 standard deviation. So it's all the scores above 91.7 and all the scores below 68.3. That's a mistake right there. 68.3. So we go through, we say 81 is between them, I'm not going to count that. 86 is between them, not going to count that, not going to count that, or that. And that leaves 1, 2, 3, 4 scores, and there is your solution. Okay, last question. Here's your quadratic formula problem. A rock is thrown from the top of a tall building. The distance in feet between the rock and the ground, t seconds after it is thrown, is given by d equals negative 16 t squared minus 2t plus 763. How long after the rock is thrown is it 430 feet from the ground? So we have to replace d with 430 feet. So here is our quadratic equation. We want to put it in standard form, which means solve for, we want to get one side solved as 0, so we subtract 430 from both sides. And we end up with negative 16t squared minus 2t plus 333. Now this is not factorable. We could complete the square. I would prefer to use the quadratic formula. So we have a, b, and c identified as our coefficients, and we're going to plug into the quadratic formula as such. If you remember, it is so important that you simplify this quadratic formula expression one chunk at a time, meaning let's simplify everything under the radical first. Well, negative 2 squared minus 4 times negative 16 times 333 is 21,316. Negative negative 2 becomes 2, and 2 times negative 16 becomes negative 32. Next thing we do is I take the square root of 21,316, and it is actually a perfect square because the square root is 146. So I have 2 plus or minus 146 divided by negative 32. If you decide to put this all in the calculator, put the numerator in parentheses, divided by negative 32 to give you negative 4.625. Then when you solve for the negative version, put this in parentheses, 2 minus 146 in parentheses divided by negative 32. That gives us a positive result of 4.5 seconds. Well, they want to know how long it took after the rock is thrown. It does not make sense to have negative time, so we must reject the negative root. The solution is 4.5 seconds. And there you have it. Best of luck to you as you study for the final exam.